Hi, everybody. I'm Chris Greco, and you are in the Data Show. I'm your host for the next 30 minutes. We'll talk about different types of data, how they work, how they interact, how to go about getting some data, how to analyze data, what's some of the things you have to watch for when we talk about different types of data, and the different aspects of what makes data studies probably for the most part biased. But it isn't as if they don't tell us that. I mean, the researchers will tell us it's biased basically by pointing out the limitations, pointing out different aspects. And most of them, I say most, not all, most of them are very, very transparent about that. So I think that's pretty important. But the reason I want to get back, I want to get back to some basics here. And this is what I want to talk about today. I want to talk about sampling. And the reason I want to talk about sampling is because I've gone out there and I have been looking at some data analytics, and I take that in quotes because it's not really data analytics. I think what's happening is the data analytics aspect is getting to the point where everybody goes out there, they take a quick course in data analytics and think for whatever reason, I now know data analytics. Well, I'm going to tell you something. If you don't understand statistics, and you don't understand the mechanics behind those statistics, then your data analysis is not going to be good. And basically what happens, it becomes a silly statistic is what happens. And what I'm going to bring up is I'm going to bring up an example today of what happens when sampling, and this is kind of a hyperbole, but still, a good example, and it comes from the late 1960s, early 1970s, a commercial that I'll show you here in a second. And it's only about a 30-second commercial, but it says everything about biased sampling that you can come up with. And then after we see the commercial, then what we'll do is we'll sit down, we'll talk about why certain sampling is biased. And basically what happens is, and I just talked to a friend of mine, but basically there's an individual out there, I will not mention his name, but he's out there doing a lot of data analytics. He's taking data from different areas and he's saying, look, this proves this, this proves this, this proves this. I'm sorry to say that his sampling is biased. And the thing is that he has a following. And basically what's happening is that these followers are believing his data analytics based on biased sampling. So what happens is, and don't get me wrong, I'm sure this guy's really, I mean, he's trying to be as honest as possible, trying to find the truth, but you can't find the truth with more hyperbole. You have to find the truth by digging down into that and hope and trying to get as much cause and effect as you can. And we'll talk about that also. And again, I'm not here to judge anybody on they're out there. The guy's passionate. He's out there doing things. You know, good for him. I think that's good. And I think that what he should do is he should point out that his sampling is biased, which he kind of does in a way. But what happens is that then he challenges other people. Prove me wrong. And to me, it's kind of like, how can you prove people wrong when their sampling is biased based on other biased sampling studies? And if you've listened to this show at all, hopefully you have at least one episode, you'll see that when we talk about data studies, we normally talk about how the media has taken a study and has basically made it, a hyperbole, a hype. And basically what's happened is that has in turn uh, caused people to question what they're doing in the way of health or anything else. So I think that's why the title today is going to be sampling, representative or biased. And there's just one test I'm going to show you that you might be able to use to figure out some of this representation aspect. Is it a representative sampling? Is it representative sample? And this is really, 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 really important because some data studies go out there and they say, oh, we have a 16,000 sample, which is a fantastic sample. It really is, but it's all from Great Britain. Or they have 10,000 from Yemen, where they have India, places like that. And it's like, that's not a worldwide sample. And it certainly is not representative of the whole world because the cultures are different, the temperatures are different, the climate is different, everything is different within those countries. So because of that, there may be factors, what they call confounding factors that exist that change the results. So my bottom line, and you'll hear this throughout the show, is if you have biased sampling, you're going to have biased results every time. If you have biased sampling, you're going to have biased results every single time. So a lot of people sit there and say, "Oh no, no, they did some representative, blah blah blah, whatever else." No, I'm telling you, that what happens is bias sampling is biased results. That's just the way it is. Perfect example of this, and one that's brought up probably more so than anything else, is the 1948 election and the presidential election. And the 1948 presidential election was somewhat of a bad sampling, right? And this was done 1936 and it was done 1948, but 1948 for whatever reason really sticks out in people's heads. And I'm doing a lot of reading on this 1948 election. I was between Truman, and not Truman Capote, but Harry S. Truman, and a guy by the name of Thomas E. Dewey. So basically, what happened is that Dewey, governor of New York State, in New York City, basically went out there, and he was a young guy, much younger than Harry S. Truman. Truman had a lot of issues. He had never been really elected as president. He had taken over a year into President Roosevelt's fourth term after he died, and had to deal with the post World War II situation, the Berlin airlift, all these different things he dealt with. And the 1948 presidential election, they said was going to go to Dewey, to the point where polls, and again, polls, I do not believe any polls. I just don't. If they have a poll and it comes out and says so and so is such and such and so and so is such and such, I don't pay any attention to polls whatsoever. I read about the two different candidates. I sit there and I gather data on my own, because the polls, if you'll see, are based on 1,000 people, which is a great deal, but you don't know it's 1,000 registered voters from which state. All states, some states, because some states lean one way or the other. So there's going to be an issue with it. Was it inner city? Was it urban? Was it rural? All these different things have to go about when we talk about sampling. So just take a look at it. 1948 presidential election. See who was supposed to win according to the polls, and see who actually did win. And that's interesting. I'm doing some background reading on that. So we'll cover those things as time goes on. But in the meantime, what I want to do is I want to show you this commercial, and it probably will bring back some some interesting memories. This is a 1970 commercial. It's on YouTube. I will give you the I'll give you the YouTube video. This is the reference right here. You can find the YouTube video at this point right here. So I'm going to show it to you in its entirety. It's 30-second. It's a shortened one from the original one, and then you can and it is funny, and that's what I try to get to. In fact, I'm writing a book on that. So we're going to this is going to be part of that deal.
How many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
I never made it without biting. Ask Mr. Owl.
Mr. Owl, how many licks does it take to get to the Tootsie Roll center of a Tootsie Pop?
Let's find out. 1, 2, 3, 3.
How many licks does it take to get to the Tootsie Roll center of a Tootsie Pop? The world may never know.
So basically, what that showed was that the little boy, he went to an animal, asked the animal, nope, I can't tell you that. Went to an owl. The owls, went 3 times and said 3 licks, and that's it. Now, believe it or not, and you can absolutely say, no, Chris, that's unbelievable. But there are situations just like that in research studies, just like that, where they go to 5 people, and they'll get feedback from 5 people, and those 5 people then will have a situation where you sit back and say, well, this is now truth, or however you want to say it, right? This is the situation. So it goes around and around from that standpoint, and you sit back and you take a look at this thing and you say, gee, that's not the way things should go. I agree, that's not the way things should go. So I guess, what is the first step what is the first step to trying to get a representative sample? Well, that's a tough one, and that's why a lot of studies have an issue with it. Let's talk about clinical studies for a second. Clinical studies really try to get a representative sample. Now, here's the problem with with clinical studies. One is most of the time you pay the volunteers, right? So people sit back and they go, okay, that's, you pay the volunteers. If you pay the volunteers, basically what you're saying is you're saying, if you want to be a volunteer, that's fine. We'll pay you. Well, there are some people that sit there and say, I'm not going to have somebody stick something in my arm or whatever for money. And there are other people that sit there and say, hey, it's an easy, whatever it is, $100 or $150 or 200 or whatever it is, or a gift card. I'm going to go and just do that. I'm going to, I'll let them experiment with me. So basically what happens is right from that moment, right from that situation, you're not having a representative sample. You're biasing your sample because basically the only people that are going to volunteer are those people that, are going to get paid. Now, a lot of people sit there and say, well, what about the ones that aren't getting paid? Well, I'm going to tell you that what happens is that this is one word that is starting to seep into every aspect of our lives. Notoriety, right? I want to be a celebrity. I want to be the first one to get the vaccine that does that, because I will be known from here on out as the first individual to get that vaccine, or the first individual to get that pill, or the first individual to test whatever. And a lot of scientists, real scientists, honest to goodness people, will experiment on themselves. They will experiment on themselves because, and they sit there and say, well, it's because I don't want to put anybody else at risk. Really? Or could it be that, hey, if this thing is successful, then it's on me. So, I mean, it's the notoriety is the thing that drives people. So you have cash and you have notoriety. And what's the last thing? Well, the last thing that could become is called altruism. And it is this is something that I would hope that many clinical trials have that, but I think that is few and far between. I think basically what happens is people walk in there. Now, the interesting thing about it is I'd have to actually do a study on why people would volunteer for that. And so it's kind of like it's kind of this circular definition thing that goes on there. But altruism means you're selfless. You go in there and do it because you want to help other people. Boom, that's it. And that's your only motivation to doing what you're doing. And that'd be some people. Some people do that. But in any case, what happens is you go out, you ask for volunteers respond to you. And then what happens is that sampling really representative or not? So I'm going to show you one way of finding out if something is representative of a larger population and see how that all goes. And this example I'm going to give you is going to be in a book that I'm writing, hopefully going to be out in a few months, about and this is about kind of ridiculous studies, ridiculous research studies. And basically what happens is that these things crop up, and the examples I give in the book are true, honest to goodness, true life things that have been studied. And what happens is that I thought, well, if people can do this, why can't I do it? I'm an MSM, right? Mass Science Management. Basically an MSM is about the same as an MBA. So I can sit back and I can do something. I can make a study. So I did. I actually went out, got a survey, made up the survey, did everything, all the different aspects to making this study a real study per se. So basically what I did was I went out and I thought about this, and I thought, oh geez, what do I do now? So what I had was here's my Excel spreadsheet. In Excel spreadsheet, I have the number of people that answered. I don't want to show you the title of the survey or anything because that'll be in the book. But one of the areas was, how old are you? And you can see here that these are the answers. Now I got all this from a place called SurveyMonkey, and SurveyMonkey is not necessarily representative, right? It just isn't. So what happens is let me just see if I can get this. I wanted to get it so I make it as nice for you as possible. So here's what I have. So I have the number of responses, and then it has the number of responses. And what happened was they gave me 226 people that actually answered the survey, which is good. I'm really happy about that. And I'll tell you why I'm really happy about it in a second. Basically, what happens is that, that I thought, now I got a problem. Is the sample that I have age, because I focused on age, is it representative of the entire country? So what do I do now? Okay, well, what I have to do is, first of all, I'm going to go to the census, right? Census.gov, and census gives you a ton of stuff here, right? I mean, this is what gives you all kind of different areas, right? So so you can go to census results, and then you can sit back and go, oh, apportionment results, pregnant data release. You can go into all these different types of areas, right? And basically what I wanted to do was I wanted to see, uh, you know, what about age, right? Age of people in the census results. So I could do search, and I could just do age, right? Um, Age, and see what the search crops up. And there's all kind of different things. Median age of the United States, total population, all the different, these are quick facts. And then different, marriage and divorce, 65 and older population, US under age 18 population, 2020 census. That's cool. Okay, so age and sex, focus on age and sex composition, and this, so I can, maybe I can go to there, population, age and sex. So now I can take a look at this, and age and sex within a population, data. So I'll just go to the data, and this is 2022 current population survey tables for household income, poverty. 2020 should give me the age, because it's every 10 years, right? So there is age and sex composition in the United States 2020. So what I did was I went to this table, and it's got, all kind of stuff here, all kind of tables. So what I did was I got population by age and sex 2020. And so it's actually perfect for me. What I was able to do is I was able to remove from that table the following: 2020 US Census, under 18, 18 to 24, 25 to 34, the different ages. And I was able to put those here. So now what I did was I thought, well, now what do I do? So I have these and I have the responses, but how do I know if it's representative? How do I know if it's the same? So I make a null hypothesis. The survey responses represent the United States population age-wise, right? And I use what they call a chi-square goodness of fit test. Now, what the method for this is, basically you're going to take these responses and you're going to figure out, how does it relate to the 2020 US Census? Now, I have a total here. I have a total here, 332 million versus 226. So that's a heck of a difference, right? So the first thing I have to do is do this. I take this right here over, in other words, divided by this, and I come up with this right here. Well, that's cool. Now what happens? Now what I have to do is I have to take each of these, right? And I have to sit down and figure out, okay, what's my population? Or here's my population percentage-wise. But I want to know, how does it relate to this? Well, what I have to do is I have to take each of these, like 74 million, multiply it times that ratio between this right here, this 226, or this, 226 and 332 million. That will give me then the number that I should have, taking into consideration the ratio between the number sampled and the total population. Now you can see here I have 50.7, I have 20.5. Basically what this is there's no 0.7 person, right? So what I would need to do is try to figure out, just take each one of these and basically take each of these and make these into a number, and then there we go. And then just take each of them and try to make sure that I can, there we go. So that's that is it right here, right? So I have that, and I have these responses. Now, right off the bat, if you take into consideration these versus these, the actual survey responses, you'll see that there's quite a bit of difference. This one right here is perfect, 21 and 21. 48 and 31 is quite a difference there. 45 and 29, quite a difference there. 40 and 28, quite a difference there. 32 and 29 and 30 and 37, not bad. So basically what happens is that, and 51 and 2, which is a heck of a difference. So basically my survey responses, I have 2 responses under 18. There's 51. Should be 51 in this spot right here. There should be 21 here, which there is. Should be 31 here. Nope. 29, 28. So right here, I'm really off. I'm really off. And that means I'm not representative. Now, there is what they call a chi-square, and here it is. So basically what happens is you get a chi-square test, and that comes out with 0.0001. That's called a p-value. Now the p-value, the chi-square p-value is less than 0.05, which I set at what they call an alpha value. If it's less than that, then you have to reject the null hypothesis. So basically that means that the survey, I have to reject that the survey responses represent the US population. So they really don't. So in other words, I am pointing out and I will point out in my report that these responses do not represent the age in US population. Now, I can do the same thing with gender. I can do the same thing with household incomes, because that's the census thing also. I could figure out maybe my household income is good. Don't know, right? I'd have to check that out. So I could do the same thing with goodness of fit for that. But the bottom line is that's just one way of being able to do that. Now, regardless of which, how do I know the 226 is a good sampling? Well, the way I do that is basically I go to what I call, and I go to I go to a place called Real Statistics, and you can look this up. It's actually called Real Statistics, and what it does is, in fact, I think I might have it here. Yeah, here it is. It's Real Statistics. It's a great. I've mentioned this on the show before. It's a great website. It's got a lot of different things you can look at. Statistical Power. It's got. I mean, this individual here, this Charles Zenitz, is just exceptional. The explanations are good, and he basically gives you a free tool that you can use in Excel called Real Statistics. And there's a lot of things you do. Look at this. I mean, you can do regression, ANOVA, time series, multivariable, correlation, and miscellaneous. And we'll be going to miscellaneous because we want to do statistical power and sample size. So this brings me to this screen right here. And as you can see, it says, okay, what do I want? Well, because I have a background in statistics, I go, well, all I want is a one sample normal, because I only have one sample. And the sample is from the respondents from the survey. And I want to know the power. I want to know the statistical power on that. When I click on this, it'll come up with a series of text boxes. And one of the text boxes is effect size. Now, what does that mean? Well, here's what it means, folks. Basically, it means that as that number is less, that's how many standard deviations between the means that you have. So what I want to do is I want to take this, if I was comparing this with something, I want to make sure that effect size is very small. So I'm going to put 0.2 in here. My sample size I have is 226, and my tails, just trust me, it's going to be one tail. And the alpha, remember I told you the alpha before is 0.05. That's exactly what it is, 0.05. When I click on this, basically it's going to give me exactly what my power is going to be. And my power is going to be 0.9. I want a power of 0.8. So I'm really in good shape here. Now let's say the more that I make this, the bigger I make this, watch my power. See, my power goes to 100. It goes to 1. The reason is because now I'm increasing the size of the differences. I don't want to increase the size. I want them to be very small. So that's where you have that. So if I wanted 0.1, you can see that if I have a 0.1, which is only 0.1 standard deviation, you see it lowers the power by half. So now I'm at 0.44. So basically, that's not the power I want. I want 0.8. So, or I want, yeah, I want 0.8. So I'm going to increase that to 0.2 again, and there it is. I get 0.91, which is perfect. So my statistical power that I'm working on this is fantastic. I mean, my statistical power for the sampling is good. It's really good. But the representative, at least in age aspects, is not good. Now I'm going to do some more goodness of fits throughout these areas just to make sure that I do a complete study. So I do different methods on that area. But basically, that's one way that you can figure out, do I have a representative sample? Just one. That's just one of many ways you can do it. Now, the way not to do sampling is, one, to go out to people you know and say, hey, have you done this? What type of effect did this have? Okay, you take all that down. Okay, thank you very much. And they go another person you know, and then another person you know, and then another person you know. You can have 1,000 people that you know, but the problem is you're biasing the sample. You're biasing the sample by doing that because it's not a random sample. Random means that all individuals have an equal chance of being selected. If that's not the case, it's not a random sample. You can call it a sample. Don't get me wrong. You can call it a sample, but you cannot call it a random sample because it's not random. So let me make sure and write this down just so you understand. A random sample means an equal chance of being selected. Okay. I mean, let's just make it very simple. Every object has an equal chance of being selected. Every person has an equal chance of being selected. Every whatever television you're checking for quality control has an equal chance of being selected. That is random. And that's why that's so very, very important to be able to make that work. So I know that droned on about this, about the sampling aspect, but I think that is very, very, very important. And understand that, I mean, and it doesn't mean you shouldn't pay attention to scientific studies. It doesn't mean it's all studies are biased. What it means is that if the methods by which the study is based is biased, and you can look at that and say that it's biased, then the results will be biased. They will be. Now, there's some out there that are really, really good studies called they're called longitudinal studies over time. I think it's called the Framingham study out of Massachusetts, I think, or Farmingham. I can't remember if it was Farmingham or Framingham. And just I think it's Farmingham. I don't know. I always think Farmingham, but it's Framingham. Okay. So the Framingham study, you can look that up. It's Framingham. And Framingham study, and you can look that up. You can Google it. And you can certainly take a look at this and say, okay, this is what we're talking about when we talk about different aspects, specifically about sampling. So Framingham study. So that's what you need to look up. And this is a really, really good study because it covered the same individuals. Now, a lot of people might say, well, Chris, it's not random. It's the entire population of Framingham that has ever had heart situations. So you're talking about an entire population, and it's only Framingham. But nice thing about it is that they've said that, and basically what they do is they work those issues that it is. But just take a look at it. It's a really good study. And that's really about it. So I wanted to say thank you so much for watching, and until next time, this is Chris Greco telling you to take a look at the data and make sure you know exactly what it is that you're looking for, because I think that's probably the most important thing. Understand you need a hypothesis. And once you got the hypothesis, then everything should flow from there. So until next time, take care, and remember, check the data.